Hello, friends. Welcome to Enlightning. We've been covering CNCF access projects, and today we're going to continue that series. We're here with Henry Avetisyan, and Henry's going to teach us about Athens. Welcome, Henry. I'm so glad you're here. Tell us about yourself, please.
Hello, Whitney, and hello, everyone. Thank you so much for inviting me to talk about Athens on the show. So a little bit about myself. I'm currently working at Yahoo as a software engineer in the security platforms team. Our team is basically responsible for security, authentication, authorization, encryption, key access management, certificate management, pretty much anything that's security related is responsible for our team. And I'll be talking about Athens. It's a project we started about maybe 8-9 years ago at Yahoo. We open sourced it, and then eventually we decided to submit the project as a sandbox project to CNCF. And hopefully we'll go through the process to make it into an incubating and eventually a graduating project.
Amazing. This is good. I'm so excited. I'm excited also because Koramaju's here. Hi, Koramaju. Thanks for being here. Koramaju's a regular and always asks really good questions. So I'm interested in kind of like you as a person. What drew you to security? How did you find your way to working with security?
So I think from the passion perspective, one thing I always liked when I went into programming, like years ago, a lot of years ago, it was all about scalability. I love backend components, and I like about scalability. And when we talk about scalability at at a big company like Yahoo, Google, Amazon, at that scale.
Yeah.
Because most people talk about like there's always the horizontal scalability. I can write a software and run it, 1,000 of them. But at the same time,
from the big draws of Kubernetes, right? Is that scalability?
But at the same time, you also want to do a little bit of vertical scalability, and that's where I find it like a little interesting. Like how do we best utilize the resources on one server before we go and deploy thousands of them? Because yes, horizontal scalability is great, but you also want to pay attention to vertical scalability. So that's always been one of my passions, is the whole scalability aspect. And then at Yahoo, we started. I actually started as a different team called Core Technologies. It was basically core set of libraries. And then along the way, we started thinking more about security, about service authentication. That was like a big piece that was kind of missing from our solution. We had some other solutions. I'm sure we'll talk about that a little bit later. And then we started, thinking about security, and I got really excited about the whole, while in school I had taken classes about security, encryption, decryption, and such, but this was an opportunity to go full in and design a solution from scratch to address a specific need at Yahoo. And that's where I kind of started, and now and then team grew and grew and grew. And now we have our team is responsible for the whole suite of security related applications.
Wow. That must be a satisfying feeling to have, your project grow.
Exactly. And every time somebody asks me when we interview people and they go what, so I've been at Yahoo now 13 years, right? So one of the questions well, why do you stay that long? And because, typically people leave 2-3 years after they get hired at a job or something, The interesting part is in the security space, there's so many different things happening, right? You look back 10-15 years ago, it was all about our data centers and nothing else. And then, we started having public clouds. Now, big part of our security, which big part of our Athens we talk about is we need to handle the case where you no longer have a private cloud. Now you have a hybrid cloud. We have, even at Yahoo, we have applications that we are deploying in our data centers. We have applications deploying in AWS. We have applications deploying in GCP. You no longer have this, oh my God, this is my private IP space. It's completely, I shield it from the rest of the world and I'm all good because I have network ACLs. Now it's it's completely all wide open, and they need to communicate securely across all 3 platforms or 4 platforms and stuff. So this actually, there's always new things coming up. We have to keep innovating, keep coming up with new solutions, keep monitoring, see what's going on in the world. How do we improve our security? And because there are hacks happening all the time, right? Nothing stops.
Yeah. Because we think about workload scaling, like we were just talking about, but then how does the security scale as the workload scale?
Exactly.
It's a hard problem.
Security is a big aspect of it, right? So yes, you have again, from our perspective is we always think about multi-tenant clusters. We never
Uh-huh.
think about a single tenant. So you can think of, for example, when we look at it internally, for example, Yahoo, you can think of Yahoo as one company, but it's not. Yahoo
Yeah.
has a whole bunch of products, and we treat them all
Mm-hmm.
independent. So every time you come up
Mm-hmm.
with it has to be a multi-tenant and has to be
Mm-hmm.
separation and delegation. Like one product should not be able to access somebody else's product. Yes, they're all part of
Mm-hmm.
the one company umbrella, but they're completely isolated services or workloads running that we need to completely secure them from each other.
Yeah. And as multiple acquisitions happen too, like it really is like literally different companies within one big umbrella company. Yeah.
Exactly, yes. And if
Uh-huh.
you come up with solutions that are, like, again, thinking back, 20 some years ago, it was always like, great, we'll come up with our own solution, we'll design our own solution, some proprietary internal solution. But now, as
Mm-hmm.
we're doing this, you want to come up with a solution that's kind of like completely standards based. Even
Yep.
though it's a product that we developed at Yahoo, one of the
Mm-hmm.
driving factors was like, how do we make sure that there's nothing proprietary there? Like, it's all completely
Yeah.
standards based, because when
We're,
there's a new acquisition, it's much easier to integrate as opposed to like, hey, you need to change everything. It's also like,
yeah.
it's the other way true as well, right? Like, if you have a product and you say, oh, we're gonna basically divest one part of the company,
Mm-hmm.
then in that case, when they go outside and then somebody else buys it, it's a good advantage to have to say, hey, we are using
Yeah.
standards-based solutions. There's nothing
Mm-hmm.
proprietary. So in a
Yeah.
sense, it works both ways. So it both, in a sense, every time we come up with a solution, we go, has to be like a standards-based. So whenever we do
Uh-huh.
whatever, it's better to integrate with everybody else.
Absolutely. When you put a product into the world, like then the community will build their own integrations to what it needs to be. If it's a standards-based thing,
Yep.
it's a lot more likely to happen. We have a couple of questions from Koramaju, but I actually, before we get to Koramaju's questions, I have I'm starting to develop a mental model, or trying to. So we've done quite a series of access tools. So we've talked
Mhm.
to. I say we. It's just me in a bedroom in my house. I talked to like Hexa and Dex and Keycloak and Spiffy Spire. I've talked to a lot, and I'm kind of feeling like I have like a maybe I forget what the kind of an XY axis in my head, and it's like one. Let's say the X axis is I made a gesture of the Y and said X. Let's say the Y axis is like humans are like access for humans versus access for processes. Um, and then the X axis then is like authentication, like once you're getting into the system in the first place, versus authorization, like moving requests, like
Mhm.
how much access do you have once you're in the system. And I think maybe all of the different tools fall somewhere on my graph. Is that a do you
Yes.
approve of my mental model?
Yes. So in a sense, like, when you think about Athens, if you think
Uh-huh.
about Spiffy and Spire,
Uh-huh.
very similar in that. So when we talk about Spiffy,
Okay.
service authentication, it's very similar to
Uh-huh.
Spiffy, because we use Spiffy URIs. And our certificates are very, they're compliant with these Spiffy SVIDs. So they're, in a sense, in
Okay.
that model, they're very identical, right? So they don't do the
Uh-huh.
authorization piece, which we also have, because it's an RBAC-based authorization. But
Mm-hmm.
yes, we do service authentication. And one thing we explicitly decided from day one is what
Mm-hmm.
you mentioned, is the human aspect. Human
Mm-hmm.
aspect, the user authentication authorization is kind of like, well understood, right? You have
Yeah.
Auth0, you have Okta. They provide user identities.
Uh-huh.
So in a sense, like, we didn't want to reinvent the wheel. All the
Yeah.
solutions
Yeah.
are out there. They
Wise.
work
Mm-hmm.
perfectly well. So in fact,
Mm-hmm.
one of the requirements, like, if you want to adopt Athens, is
Mm-hmm.
because we have all this delegated administration, we have some people who need to manage all these services, configure
Mm-hmm.
them and such. The first thing you want to do is you need to write a small integration, like an authority, that says, who is your user authority?
This is this
Whether
is
it's
we're too
Okta,
this is too
Auth0.
good. I need
Yeah.
to be
So,
behind the light board for this part.
okay. Yeah.
So
So
I'm
that.
gonna I'm I'm gonna start moving over there. But like overall, the mental model, or being able to think of any access technology along those two lines, those two qualities, that's a valid. You feel like that's valid?
Yes. Absolutely.
Okay,
Absolutely.
cool. That's thank you. That's validating. I needed that. So I'm gonna ask Kormaju's questions.
Sure.
And while I jump behind, so I'm gonna ask them both at once because I'll be a little distracted while I move. So what kind of managed private cloud does Yahoo use? And does Yahoo use containers and Kubernetes?
So our managed private cloud is our own data centers, which we have all over the world. They're all OpenStack based. As far as public cloud, if you follow the announcements that Yahoo has made over the years, so we have a big announcement with AWS where we use AWS as a hybrid cloud, and then also we recently made another huge announcement that we'll be using GCP as well, our mail component. So if you look at those, there's the big three that we're using is the private cloud, AWS, and GCP. And as far as containers, yes, we have significant number of containers and Kubernetes clusters. In fact, if you want to go back and our Kubernetes team did a big talk at CNCF. Let me think about this one. Was it 2018 or 2019? The one in San Diego. They had actually big, nice talk about the scale of Kubernetes clusters and how they're using Athens within their Kubernetes clusters. So we have a very big one. Obviously, in AWS, we now also take advantage of EKS. In Google Cloud, we take advantage of GKE. So in a sense, we have Kubernetes clusters everywhere and anywhere.
You get out. Hi.
Hey, I was gonna say you disappeared and then okay.
No. I'm having a difficult time moving my sound to the other one. So, but I'm gonna have you just keep talking a bit while I figure it out. And before, I'm actually gonna drop these links in the chat too. So I would love from the chat to know what kind of tech you're using for authentication and authorization. Also, if you just want to say hi and where you're viewing from, I always love that. Am I a double for you?
Nope.
Okay, cool. And then, Henry, I think it'd be cool for you to talk about the Athens community, because it seems like Athens is pretty strongly tied to Yahoo. Is that true, or do you find a lot of companies are using Athens?
Well, not yet. That's one of our in a sense. Hey guys, so that's one of our challenges right now. Is one thing we need to do right now moving forward is we're trying to advertise and publicize more. So right now, I think we have only 3 companies using Athens. Obviously, Yahoo itself uses it internally. There's the other company, which is called Yahoo Japan, but it's not necessarily Yahoo Japan. It's called, it's a completely separate entity on its own. It just has the name Yahoo part of it. And now it's actually called, they've changed it. I think it's called Lime Corporation. They're also big in Athens as well. So they're the 2 of us are the biggest contributors, adding new features, functionality. There's a Vespa.io, which used to be part of Athens, Yahoo. Now it's a completely separate company they're using as well. So there's a lot of smaller, I want to say companies. They're not using them in production. They've tried it out. But one of our challenges right now is to publicize more and talk about the benefits it provides. And this is one of the why we're so super excited to be here and talk about this on this show.
Amazing. So glad you're here. And I just think it's such a huge gift that I get to have these conversations with experts like yourself. It's so wonderful. Did I just hold on? I'm having a hard time. So I changed my setup, so I have 2 computers now instead of 1, but I just clearly don't have my my routine figured out. So thank you for your patience.
Sure.
Does anyone have any questions for Henry right off the bat? And yeah, where do you want to? I always like to start with a question like, what was the world like before Athens existed that caused it to get created?
Okay. So if you think back 10, 15 years ago, right? We only had our private cloud. So if you had a private cloud, you have services, you have all these hosts that are communicating with each other. Initially everything was there's some authorization method, and authorization method was typically, hey, we're gonna do communication based on IP addresses, because that's all basically they had, right? So this IP address is authorized to connect to this IP address and such. Everything over HTTP, everything plain text, nothing was encrypted.
Wow.
That's where we all started. And then, things happen and go, somebody can look at the traffic and still access tokens because everything is being, sent over in clear text. So the evolution was like, okay, so we have HTTP, we should do HTTPS now, right? TLS was taken over, everything started like, hey, we need to be secure now. So the second part was, the second step was, okay, let's move everything to HTTPS. Now everything is secure, everything is encrypted, right? So at least we solved some of the problems. Then obviously at the same time, the whole zero trust concepts were being developed and people were talking about zero trust more, right? We can no longer rely on the fact that I have a private cloud and I have IP restrictions based on ACLs. Nothing is, everything should not be secure just because it's in my private cloud. So we started thinking about how do we authenticate? So if you look at the zero trust core principles, right? So like the major ones are like, okay, it's encryption, you want to do authentication, and then you want to do authorization because authentication itself is not enough. So we decided to look at our structure and see exactly what we're missing. So obviously I kind of mentioned, right? Humans were kind of like well understood. We had whatever solution was out there, it was good enough. They all provide authentication, they provide 2FA, and everything is good. But we didn't have a concept of what's a service identity. How do we identify our services? Because the host itself was not good enough. Because remember, at the same time, we were starting looking at the public cloud. Public cloud, for example, you look at AWS. AWS, not everything is a bare metal host. You have AWS Lambda, you have AWS ECS running on Fargate, and then you had Kubernetes. You have Kubernetes, somebody would set up their Kubernetes cluster. Now they have 10 different services running on one worker node. Having a one identity for the worker node was no longer sufficient for our needs. So we decided that we need the concept of a service identity. So we have a service identity. We said, how do services authenticate, right? So, and this is where we talked about like, hey, we want to use standard-based stuff. And we were already doing HTTPS, so we had TLS. We were, in a sense, authenticating our servers, right? But how do we authenticate our clients? So we said, hey, we should take advantage of mTLS. We do mutual TLS communication. For mutual TLS, you need X509 certificates, which is great. It's all good. X509 certificates, all standard-based. But now this is the catch-22 problem. For me to do an mTLS, I need to have a private key and a certificate. But for me to get the private key, how do I get one? So we have all these services now running everywhere. They need a private key. So I need a way to get the private key. So in a sense, if I generate a private key somewhere else, I have the distribution problem. How do I securely give this private key to all my workloads? So this is where like we decided, well, what should we do? So the idea was we need to come up with a solution where the private key is actually generated by the workload and never leaves that workload. So in a sense, you solve that first problem that I no longer have a distribution problem.
So
yes.
As security is evolving in the cloud native space, like in distributed systems across the hybrid clouds, the human aspects are being solved, but like services and machines like interacting with each other, that we kind of talked about it up top. That's I'm hearing two problems. One is, well, I guess it's two aspects of the same problem. The main problem is, how do you scale? Like, how do you authenticate across the cloud environments, and how do you scale? Is that
yes?
Is that
and
correct?
Also, yeah, the authentication is the more important part, right? So scalability comes later, but initially, yes, you need to authenticate. Because if you look at the interesting aspect about this one was, if you look at each cloud provider, they provide you with an identity, right? So if you deploy something within AWS gives you an identity. It gives you role credentials that you can use to authenticate against all other services. But it's a proprietary thing, and you're not going to use that to establish encrypted communication with your own services. So in a sense, you need something that works within your, in a hybrid cloud environment within all your services. And this is where the mTLS comes in and the extraordinary certificates come into play.
So the quick question, before Athens, the problem was, how do you authenticate services across clouds and data centers? I meant to write on clouds and on-prem.
Yes.
Because data center. And that, at least at the beginning, was the problem statement for when Athens was being created. Okay.
So then we decided, okay, so mTLS was our solution because we wanted to use certificates. And now the problem is, how do I get you a certificate?
So
how do I distribute the private key?
All right. So Athens, hi, Feels Novel. So Athens is looking, of course, wants to use X509 or mTLS, right?
Yes. So we decided that as an identity, we want to use an X509 certificate as your identity.
Mm-hmm.
So then the problem that we need to solve now is, how do we get you a private key? Because then once you have a private key, you can generate a CSR and request a certificate from somewhere, right? Whatever the authority is to issue certificates.
Mm-hmm. I don't know if I want to write the question on the board, since you told me that we might have a space issue. So instead of writing, how do we get the private key? Like, so that's the problem. And then
so our solution, the main requirement we came up with, so to start with, so our requirement was, we're not going to distribute private keys. The private keys will be generated by the workloads themselves on whatever hardware they're running on, whether it's it's a in process, whether it's a bare metal, whatever it's running, on-prem or public cloud. So we're going to generate private keys on by the workload themselves. So then once we generate a private key, we have a CSR. Now we just need to have another component that can validate or attest for that workload to issue a certificate for it.
Yeah.
And that's where Athens comes in as a solution that allows you to get certificates for any workload running anywhere based on some type of an attestation data.
So is Athens a CA, among other things?
It acts as a CA, yes. It will have its own interface to act as a CA. So it issues certificates, millions of them, to anyone. So here's, I think, what I want to talk about, a little bit about the architecture part, which you understand exactly how this works.
Okay, before you do that, I would like to have like a definition of Athens is kind of definition, especially for folks when they join the stream late, they can catch up. So Athens can act as a CA.
Right. So Athens is in a sense, it's a set of services that provide service authentication. It acts as a CA to issue X509 certificates to any registered service.
You're a bit ahead of me. It's a set of services so it does several things. So I'm going to make it into a list. It does what? What's the first thing?
It provides service authentication.
Okay.
So its job is to validate and issue identities to all registered services, and those identities are identified by X509 certificates.
Okay. It provides service authentication. The second thing was just using X509 certificates.
Right. In a sense, like, it provides service authentication by issuing identities to all registered services, and the identity is in the form of X509 certificates.
Registered services. REGISTERED services, and then identity in the form of X509. If folks are watching and they're not familiar with the PKI infrastructure and the X509 certificates, I did a cert manager episode way back when, and in that one we talk a lot about what X509 are. We have a question from Code with Sean. I need to refresh here because my questions aren't showing up. Is Athens a competitor to Keycloak, or can it be used with Keycloak?
It could probably, it's not a competitor to Keycloak. It could be used with Keycloak. If you think about, if you design what, if you want to define what is a competitor in a sense, a better comparison would be the authentication part. It's very similar to what SPIFFE/Spire provides. So, because we, in a sense, like, we give you an identity. Same thing with, SPIFFE defines, right? It's like, it gives you an identity. And in fact, our certificates are basically SPIFFE compliant. They include the SPIFFE URIs. So I think if you go back 2 weeks ago or something, where Whitney had a guest about talking about SPIFFE, exactly same concept.
Yeah, that's when I was writing it out. So does it feel like a competitor, or is it something that they can integrate with each other?
It's more like a competitor, like not the SPIFFE part, because the SPIFFE is the spec. Spire is the, in a sense, like, you can think about Athens as a competitor to Spire part. So
okay, got it.
There's
so
like
another
there are a couple of things.
Implementation.
Exactly. I think to be completely compliant with SPIFFE, you also need to have the workload API. I don't think you can add the workload API if you want to our agents. We'll talk about that a little bit later. But that's it's in a competitor wise, you can think of it as a competitor to Spire, as opposed to Keycloak.
Code with Sean, based on my limited understanding from doing these shows, Keycloak is more focused around authenticating humans to a system altogether. Like, we talked a lot about a login process to a system and how you can design that for humans to use, and how you can design that through Keycloak.
And then the second part, which Athens provides, and we'll talk about it, it basically provides an role-based authorization system. So this is basically, again, based on industry standards, OAuth 2 access tokens, and it gives you like, role-based authorization system that products can use.
I'm going to, because we're talking about authentication, I'm going to use their abbreviations, I bet.
Yes.
So I will introduce them. Authentication, authorization.
Right, and this is like a little tidbit information, like, in case you were wondering how Athens comes in, where the name is coming from, it's basically auth N and auth Z. So we decided to combine them, so it became auth N and Z, and if you pronounce it, it becomes Athens. So that's where the name comes from. No Greek relation, not related to the city of Athens with an S. So that's where the name comes from.
Auth N plus auth Z equals auth N and Z equals
Athens. There you go.
It's E and Z though, right?
Yes, E and Z.
Yeah. Yeah, I like that. So Athens is a set of services. Ultimately, it works with authentication and authorization. So authentication, it issues identities to services with X509 certificates. It's going to aid in mTLS. And then it has a role-based authorization system, which presumably is for those same workloads, for the same.
Yes.
Yeah.
Exactly. Because if you look at the zero trust security concept, is like you authenticate first, but authentication itself is never enough, right? You have to authenticate and you have to authorize. So that's basically, it gives you a full solution for that aspect of that. Hey, services, they need to authenticate, they need to authorize. So we give you now a certificate plus an access token, two completely standard-based components that you can implement security for your products.
Just highlighting the definition.
Okay.
So you were starting to go somewhere before I interrupted you and said I would please like to talk about what it is. I think maybe an example is what you were about to start with.
Yeah, I think here, I want to talk about the authentication part, because I think that's the core functionality that we need to provide. Is how do we give identities? Because somebody needs to verify these people, all these workloads, right? They're running everywhere. How do we know who's what?
The authentication part.
Yes.
How do we give identities? Okay.
So I'm going to talk about a couple of things here just to give you context. One thing I mentioned earlier was when we were designing the solution at Yahoo, remember, from day one, a couple of requirements from our teams was, first of all, everything has to be a multi-tenant, right? Everything is completely separate, has to be some type of a delegation. So you have all these products that are acting independently at some point or another because they're completely their own products, yet they want to be able to communicate with each other. So there has to be some inner trust between all these products, but at the same time, we want to be completely independent. And then when you look at the product, the way it's designed to be, a product always doesn't stand on its own, right? So I have services within the product, but they're not all identical. So if you look at a product, typically when we do the deployment, we have our production environment, we have a staging environment, we have a testing environment. So in a sense, we have services running in all these environments, and we want to test them. So we had to add this idea that, we need to have this concept where all the products are represented. We have multi-tenancy and then multi-delegation, and we need to all represent them in Athens. So we have this concept of domains, and I will probably be using that a lot. So I want to define that, what the domain is. So domain, in a sense, it's your product that is isolated from all other products within your company. You can run multiple instances of Athens, right? Nothing stops you to say, I'm going to have 20 different deployments of Athens, but that's not what it's designed to do. The way it's designed is you have a single Athens installation for all your company. And then within that Athens installation, all your products are completely independently identified. And that's where the domain concept comes in. So every single product will get a domain. So for example, you might have a domain called sports, one called news, one called finance, right? Because these are all, for example, our verticals, right? We have Yahoo Sports, Yahoo Finance, Yahoo Mail. So that's where the idea is you have this one product and that's identified as a domain.
So a domain is an Athens construct that provides a way to isolate products from one another.
Yes.
Can we, is products the best word?
Yes, I think it's probably it's a good word too. Yes, that's what you use internally quite a bit to explain it.
Okay.
Think of it if you want to, another good word to say is think of it as a, if I want to do a little bit of Kubernetes relation here, think of it as a namespace. Right. So
yeah, that's what I was thinking too.
Yeah. So that's exactly often people people who are more familiar with Kubernetes think of domain as a namespace. So you have all these unique namespaces that are running. However, the domain also has the concept of subdomains, right? So for example, if you have a product called sports, so sports doesn't include a whole bunch of stuff, right? So you have sports, NFL, NHL, NBA. So in a sense, you need to have subdomains. And then I talked about the environments. You also need to have a prod environment, stage environment, dev environment, integration environment. So we have this concept of domains and then subdomains. And then now,
so the an environment would be a subdomain of a domain.
Yes.
Okay.
So you have something to give you an example, you can say sports.nhl. prod. That's your subdomain.
Okay.
So now you have like a 3-level subdomain. So you have sports.nhl. We use that as the separator of subdomains. So in a sense, it gives you isolation between all your environments.
But subdomain might be used for other things too besides environments, or is it definitely for environments?
Typically, at the end of it, it ends up being an environment. So in a sense, like, it's a product, but then we always recommend to having the end one is basically a subdomain for your environment, because that's how you isolate all your environments from each other.
Mm-hmm. Okay.
Sean, to answer your question, yes, it's a multiple level of subdomains. Exactly what you said, like, NFL, football, sports.net. So net would be the subdomain of sports, sports is subdomain of football. Correct. That's exactly what we do. So you have all these subdomains that uniquely identify specific environment. And then within there, now you define your services. So the service comes into your subdomain. So, and then you also define, we'll talk about the roles and policies that comes later on the authorization part, but let's now focus only on the service part, right? So you define your services in your domain. So you can have a service called API, but because we're not using a single level across the whole company, you might have something like sports.nhl.prod.api, and that's different from sports.nfl.prod.api. The service is called API, it's the last component, but they're completely independent now, and they're uniquely identified.
The service is within a subdomain.
Yes. So now that we've established you have a domain, you have a subdomain, you have a service defined, obviously we have this all fully delegated, right? So the domain admins for this sports.api could be separate from sports, so it's completely full delegation. I come in and I go, I want to define a service called API. So the primary question now is, how do we validate this request when a request comes in and says, I want a certificate for service called API in my sports.nhl.api subdomain? How do we validate this and give you a certificate? Because that's the core functionality here, right? So this is where probably I want to describe a little diagram. Actually, I think we also have the diagram in one of the links that you also posted there. So we can easily follow that as well to understand what the service authentication model works. So we have this concept of providers, because at the end of it, if you think about this, Athens itself has no concept who's deploying what, right? I can't go and say, well, Athens is going to be able to validate these things, because it can't. It does not have any information. It's a service running on some box. It has some configuration. You've configured it, great. But there's no concept of, no, how do I validate this? I just deployed a function in AWS Lambda, and that Lambda connects to Athens and says, give me a certificate for my service. How does Athens know who you are, or how is it going to give you a certificate? So we introduced the concept of, we decided that this has to be fully extensible, because Athens itself has no knowledge about how these workloads are deployed. It's somebody else who's responsible for it, right? There's something that's out there that is responsible for deploying these workloads. In AWS land, it's AWS. It deploys the application. On-prem public cloud could be OpenStack. OpenStack is the one that launched a brand new host. In GCP, that's actually GCP. They deployed something.
Yeah.
So in a sense, they're like all these components out there that know exactly what's running everywhere, except Athens. So we decided to provide this concept of a provider. So in a sense, you have some component out in the world that launches your workload. So now your workload is launched. The workload is launched. We said we want to be able to generate a private key for that service identity on the workload itself. So the workload is launched. It generates a private key. there's an agent running within this workload now. This is our Athens agent. And what the agent does, it collects its authentication details, whatever that may be.
Okay. Yeah.
And you define it per environment you're deploying this in, right? In AWS, it's something different. GKE, or GCP, it's something different. OpenStack, it's something different. So you define what that attestation data is. So workload is launched. It has an agent. The agent runs, and it generates a private key, collects the attestation data, generates a CSR, and submits the request to Athens and says, here's my information, give me a certificate.
Awesome. This is similar to what my limited understanding of Spiffy too.
Yes.
I'm feeling like it's smart. I think it's such a great solution. So the workload is created. So if it's a pod, then let's say it's a pod. So there's a container that's running the application, and then another container would spin up that's Athens within that pod. Is that what I'm hearing?
So for example, we give you a SIA container. SIA stands for Service Identity Agent Container. So all you have to do is include SIA container to be launched with your pod. The SIA container goes and collects all the information. So for example, in the case of Kubernetes and pods, there is your namespace, your service token. It knows exactly what it's called, all the information. So it collects all this information. The SIA container generates the private key, generates the CSR, collect all the attestation data, and talks to ZTS and says, I'm the Kubernetes SIA container. I want an identity for my service.
Cool.
So the Athens says, okay, so which provider you are? You said, oh, you're the Kubernetes provider.
I want to make you slow down just so I can capture these steps. So the workload's created, an Athens agent launches alongside the workload.
Yes.
So being generic, so it could be anywhere, not just in Kubernetes.
Absolutely.
And then what's the next thing the agent does?
It generates a private key.
Okay.
Collects attestation data.
So it does a few things.
Yes. It does basically like three major things. Generate a private key. Collects attestation data.
Cool.
And then generates a CSR.
Which is a certificate signing request.
Yes. And then it just submits all this data to Athens.
And we would call that, if this is the agent, what's the main running Athens called?
We just call it the server.
Just Athens?
Yeah, just Athens. Yeah. We actually have, so if you look at Athens internally, there are like, three. So we provide you with three major components. One is called management system. One is called token identity server. One is called the UI. So they're like, we give you three major services. One is called ZMS. One is called ZTS. One is called UI. So in this case, we'll be talking to ZTS. ZTS is the one that's responsible for certificate stuff. As a domain admin, you will talk to ZMS. That's where you would configure everything. ZTS is basically where the agent talks to.
Cool.
So the next step is, so the agent now collected all this data. Now we have an HTTP request. We submit it to ZTS, and they go, give us the identity. So ZTS does a couple of things first. So ZTS, we talked about the attestation, right? It doesn't know how to validate this thing, so it doesn't know. But ZTS has the concept of providers.
Okay.
And this is where, as a system administrator, you've defined what those providers are, and you've implemented those.
So, should I put this on a new line? Whatever's happening probably isn't. It needs more space, right?
Yes. Yeah, I think so, yeah.
Okay. So first, it has the concept of providers.
Yes.
Okay.
So this has the concept of provider. So when the request comes in to Athens server, it also includes which provider this is for, right? That was part of the request that came in from the agent. So in this case, because we were running, for example, a SIA container, it's going to go and say, oh, I'm the Kubernetes provider.
Okay.
So ZTS, what it does, first of all, there are a couple of things we want to do first. We want to do an authorization check. Because remember, in a normal environment, if you think about it, there are a lot of providers, right? So if you look at our own internal infrastructure, for example, Yahoo, I talked about the multi-cloud run, right? So we have a provider for AWS, we have a provider for GCP, we have a provider for OpenStack, we have a provider for Kubernetes. And me as a service owner, I run in one of those providers. However, I don't run, there might be a use case where I'm running everywhere, right? I'm deploying in same service. Again, we're talking about the same single service here now. It could be that my service is deployed in AWS, in GCP, on-prem, OpenStack, everywhere. But typically that's not the case. Typically you have one deployment model. Oh, my service is only runs in AWS, right? So in a sense, what I want to do is like from the security aspect, because every single time we do these things, we need to be a little more concerned about security, right? What if, because all these providers, they're out there. What if there's a bug in the OpenStack provider and somehow it got compromised, right? If I'm not ever deploying anything in OpenStack, I should not authorize ZTS to issue identities for my service through the OpenStack provider.
Yeah.
So I explicitly, as a domain admin, I go, my service is only deployed by the Kubernetes provider and nothing else. So this is what Athens, so me as a domain admin, I went and configured that. I authorized only Kubernetes provider to launch my services. So one of the things ZTS does is like, hey, I got this identity from sports.nhl.prod.api, and it says I want to be launched I'm launched by the Kubernetes provider. So it goes its own configuration and goes, is this service authorized the Kubernetes provider to launch? And if the answer is yes, we continue on. And if it's not, we reject the request right away. So we say, great, it is registered. So the next thing it does, it contacts the provider. So we have a nice interface that says, you need to validate this request. So it contacts whatever is registered as the Kubernetes provider and says, I just got a request. Here is the information. Here is the attestation data. Is this valid or not? Kamaraj is asking, what if the Athens agent fails on a workload? Well, basically, your workload will not get an identity. So that's basically you have your monitoring in place. So the way it works, like in the case of Kubernetes, you have your health checks, you have your liveness checks, and if it fails to get an identity, it means it can't talk to anybody. So in a sense, generates an alert right away that whoever's on call for the agent to figure out why the agent fails to get an identity.
Thanks.
Because this is like super critical, right? Because if you don't have an identity, you can't talk to anyone. So you want to make sure that the first step before your server goes live and it's put in production and goes into like, hey, I'm going to start serving traffic, all the initial checks are done. So typically the way we do it, since we're talking about Kubernetes, the SIA container is set up as an init container. So if it's successful, it means it successfully got the identity, it can continue on. And if it failed, it means your pod is not even deployed. That means you need to go figure out what's going on, fix it before you can move on. So it basically go ahead.
After the Athens server validates that the service is registered with the right provider, then what does it validate?
It talks to the provider. It says, Kubernetes provider, I just got a request for service called API, and here's the attestation data. Can you validate it? Because ZTS itself has no knowledge about this, but the provider does, right? The provider is now specifically written for that environment.
Talks to provider, shows attestation data. Provider gives a yes or no.
Yes. So it's basically like, there are two APIs. one for registration and one for refreshes. So basically, we have 2 ways, like, when a workload comes up, it will register, and then it will periodically refresh it, right? So in a sense, we have 2 operations.
Instead of yes or no, like provider validates that it's true.
Yep.
I like that better. Okay.
And then once it receives the validation is successful, then it goes to the certificate signer. Because now it acts like a CA, right? So it got all the information correct. The provider said API is valid, the attestation data is valid. In the request, there was a CSR, right? So now we submit the CSR to our certificate signer, and we say, hey, can you please sign this and give me an X5 certificate?
And then it's issued. We did it.
Yep. Obviously, like, when we talk about this, we're not going to talk about this on the board, but the whole CA part, this is like the super critical thing, right? So in a sense, when you act as a CA across the whole company, you want to make sure that the private key that is used by the CA is the most secure thing in the world. So our recommendation here is basically you don't use, like, you're not going to use a file-based. Obviously, we have like implementations there for file-based for testing and stuff, but your private key exists in an HSM device. Whether you use whether you buy an actual device, an HSM device, or whether you use like cloud HSM or some HSM solution from the public cloud, but the idea is that CA private key is the most secure thing that you want to create somewhere that nobody can access, nobody can extract. Because remember, if your CA key is compromised, this whole trust model completely falls apart, right? So the way we do it is like, for example, we create the key, it's in HSM, and you can never, all the HSMs provide you the option that says, hey, you can never extract the private key. You can sign things, but you can never extract it. So nobody can actually steal the private key and go somewhere else and start issuing certificates. So that's just like, it's a deployment requirement. You have to be absolutely careful about this last part, is the whole CA signing part.
Your CA private key is wildly safe.
Yes.
I like the idea of wildly safe. It's so crazy safe. Cool.
And this is basically where and I'm not going to go talk about the attestation data a lot, because that's kind of like, per application, per environment specific, right? But I want to spend about like, 5 minutes to give you some ideas what we're talking about here. And I don't think we have to, Whitney, we have to write on the board, but just talk about this so people get an idea how this all works. So for example, we kind of talked about AWS about it. We can use it as an AWS as an example. So AWS, like I said, anytime you deploy a workload, and again, we support like our AWS provider that we have implemented, and it's part of our open source project, is we support any type of workload, whether it's a Lambda, ECS, and EC2, whatever it is. So AWS launches a workload, and it gives you an identity. So you have an AWS role that identifies your workload. So in a sense, you can think of it as like, oh, can I use that as my attestation data? You can, but here's the problem. So for example, if your application is launched in AWS, that AWS workload is now talking to other services, like it talks to DynamoDB, talks to S3, whole bunch of them, right? So in a sense, that role itself has lots of authorization. So the question is, should I send that to ZTS? Why do I trust ZTS? Because then if ZTS is compromised, now my identity role is like compromised. So the way it works, the way we have our implementation set up, and this is where we also recommend with all of our providers, never ever send your actual attestation data that has further authorization. Always use that to obtain something else that has no authorization. So in a sense of AWS, the way we do this is, so you have your IAM role that identifies your identity that we just launched. Create another IAM role that has absolutely no authorization. Assume that role, and then send the credentials for that role to ZTS.
Okay.
Because then you can still go back to AWS and go, hey, which workload obtained this role? There's like AWS has the get caller identity. It says, oh, here's this workload with this instance ID running in this AWS account. It gives you all these details, right? And that's good enough for attestation data. But that role now has absolutely no authorization. So even if ZTS is compromised and we stole all these IAM roles, they're useless. They don't give you anything. They go, you launched a workload in AWS, but having access to that role gives us no extra authorization. So this is something when you're developing your providers, you have to be absolutely careful that you don't want to, that attestation data that you send back to ZTS.
It's valuable data.
It's valuable data. So you want to make sure that it identifies your service, yet it has no other authorization. And this is the model we're using with everything. AWS, GCP, Azure, all the providers we have, we always we don't send the actual attestation data that the workload is launched with. We always assume something else. In GCP, we get an access token, yet another one for a service that doesn't do anything. There's no authorization involved with it. So we identify services, we can authenticate the service, yet we get no extra authorization. So that's super critical if you're doing the implementation of a provider.
That makes a lot of sense.
Right, because we at every stage, I can come here and go, you know what, guys, the code we wrote is perfect, right? But that's not true, right? At the end of the time, there's always bugs. Something could be compromised, and we want to make sure when something is compromised, the impact is so insignificant that you do not expose all your services to everything.
I think that's a wise way to design anything. Like design it to fail and come back from failure. Design it to be compromised and how.
Because every single time it's important to say, I completely trust the system, but even if it's compromised, I don't expose a lot of other information.
Minimize the damage.
Exactly. So at this point, once we do all this dance, now we have an identity, right?
Now we have an identity
in a form of an X5 certificate. So one thing we probably, I don't know if you want to, maybe we can skip as well here. We didn't not talk about this one here as well. Is the interesting aspect of it here is, so we give you a certificate. When we were designing this, obviously, one common question you always ask is, how about certificate revocation lists? What if something goes wrong and service is compromised? The interesting thing about this solution is, if you notice, every single workload has a unique certificate. And then in that CSR we generate.
Should I write down what if the revocation?
Actually, maybe we should. Yeah, maybe we should. Right.
Okay.
Yeah, we should. Cool. So I think the unique identities now is every workload has a unique certificate. And the CSR we generate by our agents, we always include additional details about the workload, so we can uniquely identify which workload was issued that certificate. And
I'm a little behind you, sorry.
Okay.
I spelled revocation with a K, and so now I have the revocation. Okay. And so every workload has a unique identity.
Yes. And then every certificate that we issued identifies the workload that was issued to.
Okay.
So, for example, this is, you don't have to write this one, but for example, the use case for this one is, so for example, sports is talking to, what am I, good example. Sports is talking to the profile store to get users' profile credentials. And we know that this doesn't look right. Something was compromised, right? The profile says, this one agent is making way too many calls. Let's debug this further, see why we're getting this. If we look at the certificate content, we know exactly which workload this was issued to. And this is from the security aspect. When we want to debug it to see what was compromised, we can always go back exactly which workload that was issued to. So it actually helps our security team when we need to look at these cases, we know exactly which workload it was, right? Because before, if you think about, like, in the years past, when we issued a certificate and we distributed across 1,000 hosts, We know it's the same certificate everywhere. So how do we know which one was compromised? One of them was compromised because somebody stole the key and certificate. But now, because we're issuing a unique certificate to every single workload, we know exactly which host it actually belongs to. So the next question is, how do we revoke it? This is where we talk to, like, we went and talked to some, like, industry experts on the whole X-Finance certificate stuff to see how to do this correctly. And one thing we kept hearing was CRLs are like hard to implement. We should avoid them. We should not implement CRLs, not revoke them.
I don't know the acronym CRLs.
Certificate revocation lists.
Okay.
So this is basically where you say, okay, this certificate has been revoked, you should not accept it, and stuff, and no longer, there's a whole constant, communication between two servers, not scalable because you have to make a call to somewhere else to verify if the certificate is valid. So one thing we kept hearing was, forget about CRLs. Instead, what you need to focus on is short-lived certificates.
Like SigStore.
Yeah, forget about this. I'm going to give you a certificate for 6 months, 12 months, whatever. Issue a certificate for a day. So if it's compromised, great, but it'll be valid for a day. After a day, it's invalid. So that's what we do right now here, right? So the whole goal of the Athens is when we issue service identities, they have to be short-lived. How short-lived? It's you look at your environment and you decide how many days you want it to be. You can make it 7 days. You can make it 3 days. You can make it 24 hours. Obviously, you have to look at it and go, as you shorter you go, you have to think about
the other it's going to take. The resources.
ZTS is down. ZTS is an outage, right? Again, we're not writing perfect code.
Okay.
So ZTS is down. If you issue a certificate, something like, something significant, I don't know, a really bad outage we're having. And if you're issuing certificates for 6 hours and outage lasts more than 6 hours, after 6 hours, all your certificates are invalid. Now you have a completely outage for the whole company. Right? So you think about it. It's a balance. You go, maybe I should not do 6 hours. Maybe I should do 24 hours because that keeps like 24 hours. And then I refresh every 6 hours. So the idea is you have short-lived certificates and then you periodically refresh them.
So if a service is compromised, what you do is you don't renew their certificate.
Exactly. So that way it's still valid for full 6 hours, but after 6 hours, we know it's no longer valid because we've already blocked that instance. We already took care of the compromise.
Tani was here. I'm so glad. I love when you come. And Thindle's here. Oh, how happy. And we have a nice message from Physium saying this podcast learning sessions are one of the best, which I appreciate. Taniwa has revocation lists are slow to update, and sometimes I've seen them take over 24 hours to deploy. So even if you are using a revocation list, that sounds like it's going to take longer than whatever time you set for your revocation, for your expiration. So Thindle's here. Hi, Thindle. So glad you're here. This is a good question. Thanks for asking it. What's a summary of what Athens provides that's not provided by SIFI Inspire?
The authorization aspects of it.
So the authorization aspect. Okay.
The authorization, we have a role-based authorization system. Also, one of the things that Athens does, like I said, I think Spire, you might have multiple Spires and then you do federation and such. We don't go that model. We assume a single centralized one. And basically, you have complete full delegation with UI, domain administration, everything that handles within a single system.
Awesome. Thank you. And then,
but at the end of, and the core functionality you're looking at, it gives you service identities and X-Finance certificates. That part is identical.
Yeah.
And then I wanted to finish up the conversation we're having here is, so one of the interesting things we do, so we do a register. Obviously, registration, in a sense, you have no credentials yet. So when you do the first connection to ZTS, obviously it can't be mTLS because you have no credentials yet, right? It's a standard TLS connection. But once the registration happens, next time when you come in and say, hey, you gave me a certificate 6 hours ago, now I want to refresh it. Now that one, you have a credentials that were given to you during the registration process. And what ZTS does, it enforces that you're coming back with the certificate that was issued to you to do an mTLS call for the refresh operations. And then the other thing we do here, which is interesting, is when you're doing these refreshes, ZTS actually internally, it keeps track of all the serial numbers, everything that was issued, and then it makes sure that the refreshes are happening in sequence. Let me see. We have a couple of questions that let me ask you. Can we change the, Taniwa asks, can we change the validity time? Example, maybe something you want a 1 hour revocation because it's sensitive and you're okay with other may have some other. Absolutely. So every time you have a request, so we actually have two solutions there. You can do whatever you want. In your CSR, you can actually request how long you want this valid to be. So I can come in and go, at this time I want 5 minutes, at this time I want 30 minutes, I want this one, I want to be 7 hours. We also have further restrictions. You can also say, oh, this is a super critical service. As a domain administrator, you can configure and say, you know what? I want ZTS never issue a certificate for this API longer than 5 minutes. So even if you come in and you say, I am service API, I want a certificate for 3 hours. If the domain administrator configured it to be 5 minutes, it will say, sorry, I'm going to give you a certificate for 5 minutes only. So they give you all that full flexibility for the clients to ask it, but the domain administrators have the flexibility also to impose any type of restrictions you want. Because at the end of it, you might say, this is a super critical service. I only want 5 minutes, nothing more. You get the certificate, do 3 operations, you're done. And then next time you come in, you have to authenticate again and register again. So we give you all that capabilities. And to your second question, client APIs, everything we talked about here is everything is available to our REST API. So there's nothing proprietary, anything. It's just a full REST API. All the agents, everything, they actually use our REST API to do all this communication. So you might say, you give me a container, I don't want to use your container. In fact, for example, if you look at our Lambda implementations, because you're launching within for example, AWS Lambda, or you're running a Google Run function, in those cases, there is no agent to run, right? You need to use the client API. So we give you the client API, say, here's the API call that does all the work. So you can actually use that API within your application. So even if you're running within Kubernetes, you might say, you know what, I don't want to run the CS container. I want to use the API directly. You can do that as well.
Taniwa, you're on a roll.
I know, I'm asking all these great questions. Let me see.
I love it.
I want to make sure I'm not losing them. Also, the next question. Also, do you have anything so that if a connection is persistent, that those connections can be forced down, or is that an application-specific thing? I've seen a lot of services where the connection is established when they can keep it up indefinitely, even if no longer meets the policy. Connection, if the connection is so we don't do persistent connections because in our model there is no such thing as a persistent model. It's basically 2 API calls. One register, one API. You establish a connection, you register, you dropped off, you establish, you refresh, you dropped off. So we never maintain persistent connections. And the server side, we actually will automatically close all the connections. There's no persistent connection.
So if the user changes the credentials that need to be met in order to validate an attestation, then the system's going to pick that up. It's going to, as soon as you change
Bring
it,
the next refresh, or you run it manually. You can say, run the agent again, re-register, or refresh the certificate again. Correct. So let's see. When were we?
All right. So what we were talking about is refreshes and the process of refreshing.
Yes. So for example, one use case we see also is like, so the question we get asked, like, well, can I steal the key and certificate and keep refreshing it from a different host? And this is where the serial number part comes in. So ZTS keeps track of all the serial numbers and automatically detects that something is not correct. I give you
Okay.
like, you registered, I gave you serial number 1. When you're coming for refresh, you need to come with a serial number 1 to refresh,
Oh,
and I
okay.
issue serial number 2. Because now the
Uh-huh.
refreshes are mTLS connections, right? And then when you come in with 2, you're going to come in with 3. So 3, and then next time you want to refresh, you need to come with 3. I'll give you 4. And then somewhere in between, if another refresh comes in with the serial number 2, like there's something not quite here, right? Because you're at 4 already. Why are you coming with number 2? So when that happens, it basically revokes that service and goes, something is bad, it's a compromise, disables the certificate and generates the alert. And obviously, again, anything I talk about Athens here, one design decision we made, everything is interface based. You plug in whatever you want. Like, there's an interface for alerts, there's an interface for notifications, there's an interface for this and that. So for example, you're doing metrics and you want to do alerts. Like we have a plugin for Prometheus that was contributed, but you don't have to use Prometheus. You can use something else. So everything is interface based. So as soon as that happens, the interface gets fired and says something happened here. There's a compromise. Notify somebody, whoever that may be. Obviously, in this case, the domain administrator would be the right approach. So you send like an email notification or something according to whatever system you have. So that says your service identity was just compromised or got revoked because there was a mismatch between the refreshes. So that's another helpful thing we do here, is to make sure everything works as expected. Because remember, our prime objective was we generate a private key on the workload, and that private key never leaves your workload. Because as soon as you leave your workload, that is now some type of compromise. So every single workload has a private key, every single workload has a unique identity, and nothing should be shared. There's no reason for you to share something. It's no longer like, I'm going to create one and then share it across a whole bunch of services. That's a really bad idea. Every single instance, every single workload will have its own unique identity to work with.
So when you refresh a certificate, you use a serial number to assist with that. Is that the same as like a refresh token? Just a different way of saying refresh token?
We're not using refresh tokens here, because we still do the same attestation data. This is the actual if you look at every X-Finance certificate, it has a unique serial number that's issued to it, right? That's one of the fields in the X-Finance certificate, and that's what basically we're monitoring to make sure that the sequence is correct. So it's not a refresh token because you still do the same attestation stuff to make sure you're still running, you're still successful. So in your provider, at the end of it, remember, it's your provider implementation. So if you want to use refresh tokens, you can do that too.
Okay.
Because ZTS doesn't really care, nor it has any knowledge about your attestation data. So that's your provider implementation. However, in this specific check we were talking about, we're only talking about the serial number that is the certificate is issued with. And that's one of the standard fields in the X-Finance certificate spec.
So when you refresh a certificate, each one has a serial number that's evaluated and it changes per refresh.
Yes. You get a brand new certificate, right? So you get a brand new certificate, it needs to have a unique serial number. And that's where we keep track of it, just to make sure that everything looks good, nothing is out of sequence. And if it's out of sequence, we go, something is not quite right here. So because at the end of it is like, we're trying to help properties to monitor and make sure if there's any type of compromise, we know exactly where things are standing, right? These are just helpful things to help with all, something is hacked, something is compromised, we can figure out where things are coming from.
Excellent. Fun. Cool.
Anyway, to answer your last comment, you're absolutely right, correct. We only are part of the issuers. Once the issue is done, now the communication between two separate services is basically mTLS, and we're not in that loop anymore. You're absolutely right.
Excellent. So glad you're here, Tony. Well, you're the best. All right. Oh, and here, just on cue, let's go ahead and answer Tony Wong before we move on. So do you have anything to work with AWS or GCP workload identities? For example, they all have cryptographic identities that can be used to prove the identity to the other services.
Right. So this is what we talked about a little bit earlier. We use those identities to do in the attestation data. That's what we use to give you the X-Finance certificate.
Cool. So just added a little color to the story that we
Yes.
told earlier. Love it.
Right.
Awesome. What do you want to go over next?
Let's see. We only have one column left. Let's talk about authorization, because that's the next big thing that we support. So hopefully, we'll have enough space here. So we talked about, when we talked about like the whole zero trust, the idea was encryption, authentication, authorization, right? So we do encryption, authentication. So we do TLS for encryption, we do mTLS for authentication. But again, issuing and doing authentication is not enough. So yes, I know you are service API, but the last part is every single request should also be authorized. Are you authorized to execute this specific operation? And this is where the whole role-based authorization comes into play. The concept here is you can always issue reset to the board. Tanvia wants to do resets on the board now. I'm talking about the.
Yes, if only. While we're doing that, let's do a spell check option too, please.
Okay, so let's talk about authorization. And it's basically what our implementation is like a simple, we don't want anything super fancy. It's a basically simple role-based authorization. So you basically, and the concept is very simple, right? So you have a role, action, and a resource. And the policy is basically anybody who can assume this role is basically authorized to execute a specific action on a specific resource.
Makes sense. All right. Can it be negative? Is specifically not allowed to do this action?
So the action is basically it's either allow or deny.
Okay.
And you can do both. And if you, just an FYI, if you do deny, that takes precedence over all the allows. So even if you have like, let's say you have two policies, one denies, one allows, deny is always going to take precedence.
Cool.
So if you think about Athens now, the only thing that Athens owns is the role.
Okay.
Actions and resources are basically concepts that only exist within the service. ZTS only references, when I say ZTS, it's the token service, so think of it as Athens, just an FYI. But Athens only references the action and the resource in the policy.
Okay.
Right? So for example, think about it like, let's assume you wrote your own database server and you want to do authorization. So Athens itself does not understand what all the actions are supported by your database or what the resources are, whatever that may be, right? Because it's a RBAC-based system. It's going to give you an access token. Once you have an access token, then you can do whatever you need to do in the policy. So the action and the resource, as a domain administrator, you have that domain-specific knowledge. So you just reference them. So you can say, my DB reader's role is authorized to execute insert on table 1. Insert and table 1 are basically things that exist within your app product, not necessarily in Athens. They're just referenced. So I want to make sure, like, those are to make it understand, like, we talked about the role, action, resource. Role is what Athens owns. You're going to, as a domain administrator, you're going to create a role and you're going to add members who are authorized to assume that role. But the action and resource, they're just referenced. And from the simplicity standpoint is you create a role and then you define what services are authorized to assume that role. So in this case, so for example, in the example we used so far, you say role DB readers, and you can add sports.nhl.prod.api, which was our API service, as a member of that role. It means that service is now authorized to obtain a role token or an access token for that role, and then it will present that to the database server and go, here's my identity, here's my X59 certificate, and here's my access token. Please authorize me. And this is all based on standard OAuth 2 access tokens.
Okay, love it.
So
I love standards.
Yeah, the client will make a standard API call to token server using mTLS because it has an identity in a form of an X59 certificate. And then it will say, give me the access token. And then once it receives the access token, then it's pretty much a standard, that's usually what you do. It's a bearer token. You include in your authorization header, and then you forward it on to your product. And then the other product is now extracts the access token. All standard based. It needs to have access to the public keys because it's signed, right? So it's all OAuth standard based solution. It has the well-known OpenID configuration. If you're familiar with OpenID, is like you have the issuer. Issuer needs to have a REST API endpoint called .well-known/OpenID configuration, which tells you what the JWKS URI is. It makes the call, extracts all the public keys, and extract the public key that's identified in the access token, validates it, and goes, okay, the access token is valid. I'm going to go ahead and allow this operation to go through because I did the authorization check internally. One interesting thing about access tokens, which we do also in Athens, is replay attacks, right? So I have an identity. I get an access token. An access token is now passed as a regular authorization header, right? So people always with certificates, the nice thing about certificates is why we chose as the form of authentication was like, okay, you have a private key. People are a little bit more careful about private keys. They don't expose them. It's difficult to expose that private key completely because you should be, you kind of have an understanding that it's secure. Access tokens, what we found was people are not careful. They look at the request and go, oh, here's a request I got. Here's all the headers, which also includes the authorization header. And then if the access token is there, I can basically just steal it and replay it. So there is an RFC called mTLS-bound access tokens. And what it does is when you submit the request to ZTS and you say, give me an access token.
Can I guess? I just have a guess, and it's fun to guess. So based on the name of it, does it use the encryption that's part of mTLS that would encrypt the message to also encrypt the access token part of the header?
It doesn't encrypt the data. When you get the access token, it actually includes another claim in the access token, which is the fingerprint of your certificate.
Okay.
So we have this token. It now knows exactly which private key and key certificate was used to request that access token.
Nice.
So even if I somehow put my access token, so that's it's an RFC standard. You pass this CNF stuff. So if I somehow was not careful, put the access token, all the headers in some request, and somebody goes, oh, now there's an access token, I can steal it and replay it, do a replay attack, right? So when you do the replay attack, and as long as the product that is accepting access tokens, so we give you all the Athens gives you libraries that automatically give you this, but because it's standard based, you don't have to use our libraries. You can use any library, right? Because the nice advantage of using standard based solutions is on the client, on the receiving side, you don't have to use any proprietary libraries and stuff. So, for example, we do certificates for mTLS, all the containers. You're talking about Jetty, Undertow, Node.js, any container, by default, they have support for TLS. And they have support for mTLS, right? There's nothing Athens-specific stuff in there. It's all standard-based. Access tokens, OAuth 2 access tokens. They're bunch of libraries, Java, Node.js, JavaScript, Python, Go, that validate access tokens. And you don't have to have anything from Athens team to validate access tokens. It's a standard-based access. That's the advantage of it, right? With a new library or a new language, I don't want to use this. You don't have to go to the team and go, well, but you're not supporting Python. So for example, if you look at our stuff, we have some Go and Java code, but there's nothing Python. Yet at home, I'm saying at home. At Yahoo, we use a lot of people Python code that do mTLS and access tokens and everything, and they don't have to use anything from Athens because there's lots of open source projects already do all this work. That's one of the advantages why we do standards based, right? It's great.
Yeah.
So the mTLS one, but this one is something unique because not all the open source libraries support this. So you want to make sure like you can talk to the, if you're using some library and say, hey, can you support this RFC that does this extra check? Because now that I have an access token, I have the confirmation fingerprint in there of the certificate, and if I steal the access token and replay it, so I have a valid identity, right? It's still authenticated because it was issued by the same CA, and if I try to replay the attack, if the product correctly validates the access token, it's going to go, hold on, access token is valid, the signature is valid, but when I look at the claim, the certificate that was issued this access token to, it doesn't match what you're sending it to me. So it's a compromise. Therefore, you can actually reject the request. And this is a great benefit because people are not careful with access tokens. It's like I said, like it's one of those things where headers, we're debugging the situation. They put all the headers. They don't make sure like, they're careful not to extract it or something or take it out. But having a mTLS-bound access tokens, it actually solves this problem significantly. Now you don't have to worry about replay attacks because, you need to have the correct certificate, private key certificate, to submit the access token. And from the security standpoint, it's a big win. It eliminates yet another problem that could be compromised. And it's much
more. Is this an Athens specific thing?
Nope, it's an RFC. There's an RFC.
What's RFC stand for?
That's IETF, request for comments. mTLS-bound access tokens.
Taniwa says they carefully store all of their access tokens on GitHub.
Yes.
Perfect. As long as you do it carefully.
Yes, carefully. That's the key word there, right?
Yes.
Okay, it's RFC 8705.
You're talking Greek to me. So it's a standardization basically.
Yes. Oh, this is like RFC is like defines everything and anything, right? All the certificate format, TLS, they're all RFCs. Oh, there you go. I was just about to post it, but you were posted there. So yes, exactly, and that's what we support, and we recommend everyone to use that.
Okay.
And that's a great security feature, and that works quite well with Athens and everything. So it just eliminates yet another problem with access tokens where you can just freely ignore them and give them out. And as long as you have the proper checks in place, you have less compromise of access tokens.
Okay. I want to review everything you told me about the role-based, the authorization, and see if we want to add anything, because I've been a little selective about what I've written down.
Right.
So basically, where there are three considerations whenever you're thinking about authorization, like any authorization really. And so it's role, action, and resource. So anyone who has this role is or is not allowed to do this action on this resource. So Athens owns the role part. And specifically, it's going to issue an access token to the service. And then it's up to an admin of the system to figure out what that access token, what actions they're allowed to do on what resources. But all of the access token part is based on OAuth 2 standards. And then in addition to that Athens does the mTLS-bound access tokens, where the service's private key also signs the access token to prevent replay attacks.
Yep.
Cool.
So a couple of things I'm going to add here, but we don't have to write it.
Okay.
Very similar to certificates. When you issue access tokens also are valid for specific number of minutes, right? So you can do, again, the clients can request anything, like 3 hours, 4 hours, 5 hours, 6 hours. Obviously, the expectation is you request them, you need to keep refreshing them every X number of hours. So again, you made a decision how good this is for. Our recommendations are if this is an access token to write some data. Obviously, if it's for read data, you may not be concerned as much. Maybe you can say, I want to like, like for example, my recommendation is like, if it's a read data, you can say every 6 hours, valid for 6 hours, refresh them every 6 hours, continue refreshing them forever. If it's a write operation, you want to be much shorter. Maybe it's only for 10 minutes or maybe 5 minutes. Very similar to certificates, we also you can, as a domain administrator, because roles are owned in Athens and you own the roles, you can request a specific limits to be set. So we give you all that capability. You might say, okay, here's the role that once you have access to this role, you can actually write entries to our database. So in a sense, I'm not going to give you, I'm only going to allow to be valid for 5 minutes only. So you can actually impose those limits as well. Very similar to certificates is you can do both. You can say, you as a domain administrator, you have full control over it. Other thing we also do, which is, remember when we talk about role-based authorization, and we talk about something, because this was like used internally, we always have to talk about, as a company we may not have to, but as a public, now we're a private company, you always talk about governance, compliance, all the requirements that you have to follow because you're dealing with credit card data, PCI. So in a sense, so for example, we have all those features. We have workflow, and we allow in our Athens UI as well. So for example, roles, right? So we talked about now you can add the service to the role. Well, there are multiple ways of doing that and validation. So one is, so for example, we provide a self-serve role. Me as the owner of the service, remember when we talk about these things, we always talk about delegated administration. We also trying to also help our properties not to do a lot of work where you have to go ping everyone. So for example, so you might, for example, Whitney, you might have like, you might own the domain that, that manages the domain, the database service, right? So you own the role. So I need to come. So one option is I can come to you and say, oh, Whitney, can you add my service? And my service name is blah. And then you go, great, let me add your name to the role. We provide a self-service option. So the self-service option is, I know what the role is. I go and add my service to the role, and ZMS or Athens adds it as a pending member and sends you a notification. It says, hey, Whitney, Henry just added service called blah, blah, blah. Please come and review here. So you go into the Athens UI, there's a review page, approval page. You see my request, my justification, why I need access, and you go, here's approve, reject, and you specify an expiry date, optional one. That's the self-service option. The second one is sometimes we go, there's some teams we go, well, we don't want single domain admin to do add any members. We require 2 domain admins. So we provide you an option for that as well. So you can say, so for example, you and I are the domain admins for the database administrator, for the database domain. And the user comes in and says, I want to be, can you add me to this? I will go ahead and add that service. But even though I'm a domain admin, it still becomes a pending. And then they'll send you a notification and go, hey, Whitney, Henry, the other domain administrator added this service. Can you go and review it? So this, in a sense, like, there's that balance of 2 administrators. There's the governance also. There's some governance requirements with some of the PCI stuff that says, no, domain admins are not sufficient. You need to get an external person who is identified at the higher level up to approve all these changes, right? And then, so, I added, it's not you anymore who can approve it. That other external user that you've already configured in your domain gets the notification and says, hey, please verify it. Governance says everything has to be reviewed every 90 days, every 60 days. So Athens gives you all that capability. It sends you a notification, says, hey, Whitney, your role, you last reviewed it, 60 days ago. All your members will now expire. So you need to go into, we have a nice UI where it gives all the users, you click, get this one no longer needs access, this one extend, no, this one don't extend. So they give you that capability as well, where you can review them periodically, because that's part of it is like, this whole security thing is not, oh, let's give out everybody access and they are on forever and ever, right? The requirement is periodic reviews. You want to do periodic reviews. And this
so
implies
Athens takes like this
we
incredibly
give you all that stuff. We give you all that
tedious
functionality, all that work.
Yeah.
Nice API access. One of the things we do quite a bit now, team, like I talk about Athens UI because it's great, but most of our teams are not even using Athens UI. We have a really nice Terraform provider. It's an official HashiCorp Terraform provider. So if you go to HashiCorp's website, there's an official Terraform provider. All your administration, all your configuration, anything you can configure, create services, create roles, policies, change configuration settings, add members, remove members, everything is available through our Terraform provider. So in a sense, if your team is like, it's all about infrastructure as code, no manual changes, nobody is allowed to go to the UI, use Terraform. Submit your Terraform files into GitHub, do the review, submit it, boom, everything gets automatically provisioned against Athens system. So we give you all those capabilities where you can do whatever you want to do. It's in a sense like it's one of those, like, I'd like to call it like, full featured product that gives you all these capabilities. The only thing
it sounds like it takes some incredibly tedious compliance related stuff and makes it less as it's never not going to be tedious, but it makes it as palatable as possible.
Yes,
it takes a lot of that out of it.
And because we have to go through that Yahoo quite a bit, so it's a good experience based on that. Hey, so in a sense, like, you can take advantage of those things. So in a sense, like, we try to make it as simple as possible, as useful as possible, and at the same time, you need to satisfy all your requirements.
Taniwa is asking, do you support KMS? What is KMS? Oh, key management systems.
In which context are you asking about?
Key management. Yeah, which key management service? So those are like
what would you use KMS for? Let me ask you that.
Yeah, let's say cloud KMS, like AWS or GCP.
Well, those are like, KMS. Again, the question is like, in the context of Athens, where would you use KMS for, right? So the only place where you would use KMS, if you look at all this infrastructure in place, there are a couple of things that you want to do. Is you have two sets of private keys we talked about. One,
we have the private key of the CA, and then each private key that each workload has. Oh,
right.
Here we go.
So in a sense, like, the question is that I've actually gone one step further than that. If you look at something came up here. Second column. Let's have a column. No. Well, let's see. What are we looking at? Yes. So at the bottom of the second column, we added make sure your CA private key is widely safe. In fact, I actually go one step further. You can use KMS. We support KMS for it, but I would say go one step further, use an HSM. That's actually, you can do KMS that's backed by HSM. If you want to do that, that is fine.
I don't know the acronym HSM.
It's a hardware secure machine.
Okay.
Yeah. So in a sense, you actually have a hardware. Like, we have some of those. We have some HSM devices from Utimaco that do it, and that's a hardware you can buy, quite expensive. Or you can use actually cloud HSM solutions, which are also expensive in AWS. They're not cheap. But I think from the security standpoint,
confidential computing. We just did a confidential computing episode, or well, really a confidential containers episode. But Tobin talked about it has to be on specialized hardware. Yes. So is that the same thing? This
like specialized hardware for that, yes. And that's super secure. You can never extract anything. Hardware security module. Thank you, Abhijit.
Thank you, Abhijit.
So we actually recommend. At Yahoo, we don't even use KMS. We actually use HSM directly. And one thing we do, nice thing about HSMs is a little bit off topic here, but to sign certificates, all the HSMs provide what there's another standard called PKCS 11 standard. It's a nice interface that you can interface with your HSM, so you don't have to worry about what HSM you're using, and you can actually use the API to sign certificates, and that's what we use. Our paranoid organization at Yahoo, they have a open source project called CryptKey, which is basically this PKCS 11 implementation. So you can put any HSM device behind it, and then, but as long as you have a plugin for interface with CryptKey, then it doesn't actually. Then you have to worry about it. So because then it just uses that, and then you store it in HSM. So I think, for example, at Athens, we provide you that interface for PKCS11 interface, crypt key, and then you can use any HSM behind it. And I would strongly, strongly recommend to store your private key in HSM.
Excellent. That makes a lot of sense. What would you like to do with this last little bit of space?
Last little bit of space.
Rattle off a list of extra benefits, or we can dig into one more.
So let's talk about a couple of things in there that that are coming up, right? So it'll be good to know. So we talked about, a little bit of future stuff, which is also interesting. So we talked about Kubernetes. We talked about SIA containers, right? So one idea about the SIA container was, well, you have this extra container running in every single pod, right? So if you have 1,000 pods, you have 1,000 application containers, you also have 1,000 SIA containers. That's great.
So the SIA container is the Athens agent.
Yes, it's the service identity agent. Yeah. So we talked about that's the one that does all the work, right? Yes, that was the sidecar. But the question is, can we do something else with it? So this is, I think, what, in fact, Abhijit actually just finished up the work, and we'll probably publish it very soon, is the integration with Cert Manager. Because if you think about it, is the work of the agent was to collect the attestation data and give you an identity in the form of an external certificate. So instead of having all these agents, can we actually combine that data and put behind the Cert Manager? So Cert Manager now has all that extra logic, but you only have one of those running within your cluster, not 1,000 of them. So that's actually one thing.
Cert Manager I didn't know Cert Manager could do the work of getting the attestation data together.
No, you write the plugin for it, because it has the concept of drivers right in the back. So for example, if you look at the Cert Manager, if you look at their documentation, they say, you can have all these plugins to go and talk to other services. So what we're providing is there's the Athens driver now. So now, which has all that embedded logic now, how to do all that extra work. But the advantage is you have a daemon set running, one per cluster, instead of running 1,000 SIA containers. From cost benefits, could be beneficial. So that's one interesting concept that we're working on. The other thing we're looking at is how do we integrate with more? So for example, from CI/CD perspective, so we have another open source project that Yahoo contributed to the CI/CD Foundation called Screwdriver. Screwdriver is basically where you basically do all your CI/CD unique projects, and they have integration with. We have integration with Athens, so all your projects can run with their own identities. So another request we just got very recently, which we'll be working on, is how about GitHub Actions? If I'm running a GitHub action, how can I integrate that if I need to do mTLS call within my internal infrastructure, where I need where everything's protected by Athens certificates, can I do something with GitHub Actions? Because GitHub itself, for example, provides an OIDC support, right? So one thing we'll be working on is to see how we can integrate GitHub Actions with Athens. So if you're already using Athens and you want to take advantage of GitHub Actions, it allows your GitHub Actions to also get Athens identities. So if you're making calls to internal services that are protected by Athens mTLS CA, now you have a certificate, you can actually do that. So that's another interesting thing we're working on as well. Obviously, there is a whole bunch of other integration stuff we're working on. We have all these plugins that are available for our product that you can integrate with. And as more teams are picking up things, they'll be writing more stuff. I think there's one for another one we're looking at is for monitoring. We're going to standardize on using OTel, which is another open source stuff, to do all the monitoring and logging support for that. So that could be another another area that we'll be extending as well. And obviously, our goal is to publicize Athens as much as possible. I think that's one of our goals for this year, is to talk about more, get more companies consider using Athens and, expand the community. And this was like, it's a great first step, I guess, in the process. And I'm quite grateful for you to inviting us to talk about Athens in this forum, because this is quite useful.
It's been my pleasure. Is there anything? Well, first of all, if anyone else has any questions, please ask them now, because we're starting to get to the recap part of the show. But if someone has any further questions, or they're interested in getting their hands dirty and like maybe trying something out, where should they go from here?
So we have our website, the Athens.io. So Athens.io, we also have a Slack there. You can actually connect to it. Slack, we have a channel. You can join us. You can ask any questions there. Obviously, you can also reach out to us individually. So we have 3 main lead implementers, like it's me, and also Abhijit is on, who was on the chat as well. You can reach out to us on the CNCF Slack as well. Or we have a mailing list. Also, you can actually reach out to us. The Athens Slack is probably the best one.
Excellent. And we have 2 questions from Taniwa. Do you support using SPIFFE SPID compliance certs?
Yes, I mentioned that a little bit earlier, that all of our certificates actually include SPIFFE URIs there. So in fact, in a lot of our Kubernetes deployments, they're fully using Athens certificates as SPIFFE SPIDs.
Cool.
And the new part that you asked about, the play on the Project Athena, no, it's not. If you look at
okay, I have to uncover it.
There you go. First column, the last line. That's how we get Athens. It's authentication is Authn, authorization Auth-Z. We shoved them together, came up with the word Athens, which we thought was pretty cool.
Yeah, I think it's nice.
Yeah.
Where would I think I would
relation.
I think
and then one thing I'm gonna sorry.
I know
and then you can build a whole bunch of other solutions on top of this. One thing we could probably finish up, because I see like a little bit space at the end in the future section. If you follow our check-ins or PRs, you will hear about there. You'll see some references to microsegmentation. And one thing we are going to do is, which we have like the service called microsegmentation service. We're trying to come up with a solution for service identity-based microsegmentation. So that would be like a cool thing. We're actually right now we're testing that, and that could be like something like where you take you can create policies in Athens, and those automatically end up being defined as network policies or whatever that may be. But if you have lots of services that are running in public clouds, you can do an identity-based microsegmentation based on service identities. That's another cool thing we're actually working on right now for 2024.
Will you tell me what microsegmentation is?
It's basically we, instead of doing IP-based, because when we talk about who can connect to whom, in a sense, like instead of defining IP addresses and such, you can define them as service-based. This is like actually commonly used in the Kubernetes world, right? So Kubernetes, you can define like which service is allowed to connect to which service, and if you want to expand that,
change.
And if you expand that, same concept, like services are going to change. So I have a service in GCP, I have a service in AWS. I can do some ACL-based, IP-based stuff, but sometimes I do a little bit more. But then if I want to tie it down a little bit more and do more microsegmentation based on IP addresses, because if you go back and look at all the registration part, we know exactly where your identities are running, whether we have the IP addresses or somewhere we can identify them. And we're trying to see how we can actually make that process a little bit much more secure, where now I just say only the service A can run on service B. Service A runs in AWS account 1. But I may not want to expand my ACLs and say everybody in that AWS account can connect to me. I can shut it, get it a little bit smaller. So it gives you some ideas, like to do a little bit better security.
Okay. to look at it from the other side, maybe you look at it as if you're looking at individual processes or individual services, like maybe like small groups of them would be a small group of them
Exactly.
would be a micro
Yep.
segmentation.
Yep.
Cool.
And
I want
that's something
to
we're working on as well.
awesome. I want to say I like how Tani was excited about Athens. Going to see if they can integrate that with their work. Looks super
Perfect.
useful. I have ideas. I love it. Thank you for being here and being such a positive presence on the stream, Tani. Well, do you want me to write a little sentence about microsegmentation? I can fit it in here, or
That would
should
be
I?
probably under the future part. It's coming up,
Oh,
and
it
we'll
is a
have
future
more.
thing.
Yeah,
Okay.
it's a future thing. Like, we're working on right now, and we're trying out, testing out stuff, and we'll have probably include them in the open source sometime, maybe like this or next quarter. So that's definitely what we're working on right now.
Microsegmentation, just a whole big can of worms, just in one
Oh
little
yeah,
word at the last second.
that's a big word up there. Yep.
All right. I think I'm going to start this. I'm going to do a recap. Do you feel ready for this?
Sounds good.
Feel free. Microsegmentation is not a micro idea. Feel free to, if I don't say anything quite correctly, please do feel free to interrupt me and correct it in the moment. But before Athens, there are big changes happening in security, securing connections between workloads within a system, doing a secure, everything was with HTTP, it's becoming HTTPS, TCP is becoming TLS, and then mutual TLS, I guess. It kind of went like that. And then, but what about identities for services? So there's services running everywhere, and part of the thing is they're not just running in one cloud or one system that's shut down. They're running across clouds, they're running on-prem. How can we get them all to authenticate with each other and how can we just like manage their communications? And so Athens uses X509 certs for identity and mutual TLS, and the private keys are generated by workloads themselves. And then Athens can act as a CA, which we're going to get into later. But really, our big definition of Athens is that Athens is a set of services that provides secure authentication by issuing identities to all registered services in the form of X509 certificates. And in terms of authorization, it provides a role-based authorization system for services. And we talked about how Athens got its name, which is lovely. I like that it's an equation. So then how does Athens, well, before we really talked about how Athens gives identities, we talked about like the structure. So Athens is designed to run one instance of Athens across the whole company. So then it has this concept of a domain, like a construct that provides a way to isolate different products from one another. So similar to a namespace in Kubernetes. And then a subdomain isolates environments within a domain, and those can be nested if necessary. And then finally, we get down to a service that is going to be within a subdomain. So then the process of how do we give identities is first the workload's created, and then an Athens agent launches alongside the workload. And if you're doing that in Kubernetes, currently that's going to be a sidecar container in a pod. But it can happen outside of Kubernetes, so that's why we have it written more generically here. So the agent does a few things. It generates a private key. It collects attestation data. It generates a certificate signing request. And then it takes all of this and it submits it to the Athens server. And later you said it does this too with an identity that's disposable so that you can't trace it back to the workload. But the Athens server has a concept of providers. So provider could be AWS or Kubernetes or GCP. But anyway, it's going to validate that the service is registered with the right provider. It's going to talk to that provider and show the provider that attestation data. And then the provider will validate, yes, this is true. And then the Athens server receives validation successful. Then it acts as a CA, a certificate authority, I believe, and signs the certificate signing request. And then the certificate is issued and an identity is issued to the service. And that's how that happens. But then what if the system is compromised? So what does Athens do in terms of revocation? So every workload has a unique ID, and every X509 certificate I can identify the workload that it's issued to. So this helps to know if there is a compromise, this helps to know which service was compromised. But then here's the twist. When we talk about revocation, we don't want to revoke, actually. We're not going to do that. Instead, the idea is to issue short-lived certificates. So then if a certificate or if a service is compromised, the way to stop it is not to revoke the certificate. It's just to not issue refresh that certificate when it expires. So you can configure this certificate refresh. You can configure per service how long you want that refresh to be. Because some services, if they're compromised, you want them to go down very quickly, and you might want that to be very short, even though it's going to break your system when it goes down. With other things that might not be as scary, if it's like a video stream or something, that who cares if you lose a few packets, or if you see a couple packets of something that's public anyway, then you could have a longer certificate before a longer time before that certificate refreshes. And then as far as the refresh itself, each certificate has a serial number that is issued for that certificate. And then when a refresh happens, a brand new certificate is issued, and then a brand new serial pops up. But that serial number is used as part of evaluating when a refresh can happen, so that you have to have the proper serial number of your last certificate to get a refresh of the new certificate. We talked about SPIFFE and SFIDs because this technology has a lot in common with SPIFFE, and then you can actually use it with SPIFFE's SFIDs as part of the Athens. It supports it. We have authorization. So we've been talking about authentication this whole time. So now once your workload is authenticated, now how can we control what it can access now that it's authenticated? So anytime you're dealing with levels of access, you're thinking about role, action, and resource. So anyone who has this role is or is not allowed to do this action on this resource. And so, and you can also add time limits for this amount of time. There is a fourth optional thing. So Athens owns the role piece, where it issues an access token to a service. But then once that's done, it's the administrator of the system that's going to add the actions and the resources. So this is all based on standards, which whenever Athens can, they use industry standards in anything, which I think any project worth its salt should do. There's never a reason to reinvent the wheel. But so this is all based on OAuth2, the OAuth2 access token. And then it also uses an industry standardization where the access token itself is protected by mTLS. It's called an mTLS-bound access token, where Athens uses the service's private key to also sign the access token. So this prevents what's called a replay attack, where the one service token is used more than one time.
Just to be clarified there, it doesn't actually use the private key to sign. It just it includes a fingerprint of the certificate that was used to get their certificate as one of the claims. So we don't sign it again. We just include the certificate hash, in a sense, as a claim in the access token.
Uses a service's certificate fingerprint as part of the access token.
Yeah, it's one of the claims that gets added to the access token.
Uses a service's certificate to further validate their access token.
You can say, okay, that's fine.
Cool. So this itself is an industry standardization, and it's very very useful, and it prevents a whole dimension of vulnerability. And then finally, we talk about the future of Athens. So the integration with Cert Manager. So right now, Athens, like in Kubernetes, has to have a sidecar in every pod to be able to be the Athens agent that's communicating with the Athens server. So using Cert Manager with the Cert Manager, the plugins that you can add to Cert Manager, we could do this where there's only one instance of Cert Manager running in a cluster that could do this for all the workloads. So it's not running with every single workload. Then you're working on integration with GitHub Actions so that they could be anything. The GitHub Actions have it on their own runners, but like that whole thing can be integrated into a system that's using Athens for authentication and authorization. Athens is working to standardize on using open telemetry for observability. And then this really loaded word at the end that I'm just going to let hang there, micro-segmentation. Working on that too. I want to kind of make this process its own thing. And is there anything you'd like to add?
No, this was a pretty good summary.
Excellent. We worked really hard on it. Excellent. So we did it. Good enough. We did it. Thank you so much, Henry, for being an amazing, passionate teacher. I appreciate you. Thank you, everyone in the chats, Tadiwa, and a lot of other Kormaju, Code with Sean, Findle. I'm going to play the music again, and we're going to say goodbye. Thanks to everyone who watches the recording. I'm just going to dance a little bit. Feel free to. There we are. Feel free to move your shoulders. Thank you so much. I appreciate you. Oh, and Michaela's here. Kormaju, hello. Goodbye. Taniwa, I'm picturing you dancing right now with me. Stand up from your chair. Go shake it a little bit. Yeah.